We are now doing question 3, and there's something which I wanted you to always remember. If we see on question 2, right, the continuity equation is actually this one, but we didn't need to get this g of negative 2 because we got it in the calculation. We saw that when you get the limit from the left and the limit from the right, and you make sure they're equal to each other, you can be able to find b just using those two. The limit as x approaches 2 from the left, x approaching negative 2 from the left, should be equal to the limit as x approaches negative 2 from the right. The limits should be equal, because if they're equal, then we know that this limit here would exist. And if this limit exists, then we've done that one thing already. And it helps us to find b. There's only one value of b that basically makes the limit to exist, which is what makes it continuous. All right, so that's what happens. Okay, so now we can go to this next one. We might have to do more than that. So now we are doing it. Says, for what values of a and b is the function continuous at every x? Remember, if the function is going to be continuous at every x, we are going to test it here at these controversial points, the points where they meet, because this function of negative 2 is continuous everywhere. This one is continuous everywhere. This one is continuous everywhere, but it's continuous wherever it meets. But where they meet, that's where we may have a problem. So we should just make sure they're continuous where they meet here. So anyway, what is this first value we have? It's x equal to minus 1. So we need to make sure that at x equal to minus 1, there is continuity. Then we need to make sure that at x equal to 1, there is continuity. So what are we going to put? Let's put our f of x first. F of x is going to be equal to 3 functions. What a piecewise. This is going to be ax minus b, then 3. Okay? And here we say if x is less than or equal to minus 1. This is going to be if minus 1 is less than x, which is less than 1. This is going to be if x is greater than or equal to 1. Okay, so what are we going to do now? We're going to say the limit. We're going to have the limit. We're going to check continuity at x. Okay, at the continuity at x equal to negative 1. So we can say for continuity at x equal to negative 1, we're going to say the limit. We can first just say f of minus 1 is going to be equal to the limit as x approaches negative 1 of f of x. Okay, so here you can say let's find the limit. We're actually not going to use this equation, okay, not much, but what we are going to use is this, to say the limit as x approaches negative 1 from the left of f of x is going to be equal to, let's find that limit as x approaches negative 1 from the left. So we are approaching negative 1 from the left, which means we are less than negative 1. We use this, okay? It's going to be the limit as x approaches negative 1 from the left of negative 2. That's our f of x when we are coming from the left. And limit of a number is just a number, so this will be negative 2. Then we can now say the limit as x approaches negative 1 from the right of f of x is going to be equal to the limit as x approaches negative 1 from the right of, we are now coming from greater than 1. Okay, but we are going towards 1. So we are very close to 1. We're very close to negative 1, sorry. Okay, but we're coming from the right. We are bigger than it. So that is this one, bigger than negative 1. But we are still less than 1. We're very close to it. So we're going to use ax minus b. This is going to be of ax minus b, which is going to be, we substitute, because this is just a polynomial now. We have an x. Wherever there's x, we just substitute this minus 1. So it'll be a by minus 1, then minus b, which is going to be minus a minus b. This is going to be the second limit. Now, what are we going to have now? We have now to find for continuity. We can say the limit as x approaches negative 1 from the left of f of x should be equal to, so we'll say, for you to know, say let the limit as x approaches negative 1 from the left of f of x be equal to the limit as x approaches negative 1 from the right of f of x. And what is that going to be now? This we found it to be, as we come from the left of f of x, what did we find it to be? Negative 2. It should be equal to, what did we find this other one as? Negative a minus b. So negative 2 should be equal to negative a minus b. And we can take a to the other side. We have a minus 2 should be equal to negative b. And if we want, we can take this negative to the other side. We have negative of a minus 2 is going to be b. So we have found what b is, okay? We can say now that b is going to be equal to negative times a is negative a. Negative times negative 2 is going to be plus 2. So we can just say b is 2 minus a. This is going to be the first equation which we have found. And now we can go to the next one. All right, we'll do the next one now. Let's do it. Now we'll go to the other controversial point, which is at x. So we can now say at x equal to 1. I mean, we didn't even have to do too much of this. We could just, do it like to find the limit as x approaches 1, whatever. But we can just say we have f of 1 is going to be equal to the limit as x approaches 1 of f of x. This is a big statement because it's saying that this limit should exist and it should be equal to 1. It should be equal to this output when you put 1 in the function. So if we're saying this limit should exist, then to make it exist, the left-hand limit should be equal to the right-hand limit, okay? Which is what we are letting here. So we would be saying, now let's get the limit here. The limit as x approaches 1 from the left of f of x is going to be equal to the limit as x approaches 1 from the left, because that's the other controversial point. We're coming from the left, which means we're less than 1, but we'll be very, very close to 1 because we are approaching it. So it's going to be here. We are less than 1, but very close to it as well. So this is going to be limit as x approaches 1 of ax minus b. So this is going to be x is approaching 1 from the left. So we are putting 1 wherever there is x. So it's going to be a by 1 minus b, which is a by 1 is just a minus b. So this is going to be the limit. Then now we can say the limit as x approaches 1 from the right of f of x. This is going to be the limit as x approaches 1 from the right of, what are we going to put as our f of x? We are now coming from bigger than 1 because we are coming from the right of 1. Here is 1. Okay, so it's like we have 0. Then we have 1. Here's our number line, right? 0 and we have 1. We're coming from the right of 1, which means we are bigger than 1, okay? That's just so. If we are bigger than 1, then we are going to take this. Our f of x will be 3. So it's going to be the limit of 3, which is the limit of a number is just the number itself. So it's going to be 3. So now we're going to say let the limit as x approaches 1 from the left of f of x be equal to the limit as x approaches 1 from the right of f of x. This is going to be, as we come from the left, we found it as a minus b. So a minus b should be equal to 3. But we know what b is. From here, b is 2 minus a, okay? 2 minus a. So we saw that b was 2 minus a. So now we're going to say b is, you say, but b is equal to 2 minus a. So you can say a minus 2 minus a is equal to 3. So this becomes a minus 2. Then minus of minus a becomes plus a. This is going to be equal to 3, right? And what do we have now? A plus a is 2a. Minus 2 is equal to 3. This minus 2 goes to the other side. We have 2a is equal to 3 plus 2, okay? Because it will go to add. 2a is equal to 5. A will be equal to 5 over 2. Now we can have, okay, and then we can now say, what did we say b was? So you can say b is equal to 2 minus a. So you can say when a is equal to 5 over 2, b will be now equal to 2 minus 5 over 2, which is going to be equal to negative 1 over 2. You can put in the calculator. You say 2 minus open bracket 5 over 2 close bracket is equal to. You get an answer which you can now say second function. You say second function, then you press this button a, b over c to change it to a fraction. Any number to a fraction, improper or whatever, you get it negative half. So this is going to be your final solution. B was negative half. A is 5 over 2. So you can say a is equal to 5 over 2. And b is equal to negative half. Here are the two things. And we are done.